our CTO, Søren Debois, actually talked about his daughter. She is in high school. And every time she buys something, she gives it to ChatGPT and says, improve it. And then it improves it. And of course, she selects some of it. I do the same. It's not because I take everything, but sometimes it gives me ideas. So you can say, I use it as a coworker for getting input, and it's cheaper than disturbing my coworker to get that input. I still also disturb my coworker, but then I have probably increased the quality before I disturb my coworker. And I think that's a win. That's a win-win for everybody. Just a small example. So I agree with you. It's not replacing, but it is sort of enhancing. And I think that is the thing. You've probably seen these things that people are talking about, especially the one with Google that lost $100 billion overnight because they made a mistake in this launch of Bard. I think it says something about investors, but it also says something about Google's business model is under pressure at the moment because they used to make a lot of money on search. If search will be replaced by sort of these type of interfaces, of course they will be in trouble. And I read something about somebody say that Google actually was ready to release Bard a long time ago, the competitor to ChatGPT, but they couldn't do it because if they did it, they knew the quality was not sufficient. It's easy for a startup not to have high quality, but it's not possible for large corporations to have large quality. But when the business model changes, people are generally in trouble. I think this is what we witness at the moment. And I think everybody has to find out how to use these things. And so as the first thing I actually tried to do, I actually asked ChatGPT, could it actually create a customer reference, what's called CRM system, customer relationship management system for them. And I asked, could you please create the database script? And then he created this script here. I just want to sort of say this was the table, the customer table. Is this a good customer table? Anybody can see some, is this reflecting what you would need when you have a customer table?
Yeah, with very basic information.
Very basic information. Will it work? Will it work? Somehow. What will not work? Because I see one thing, I can guarantee you that it won't work for one simple reason. If anybody has a name that is not from A to C in American, US American, it won't work. It will only work in one time zone. So all they need. It will only work in one time zone. Okay, there's no date here, but there was a date in one of the other fields. So when you do things, right? They use a date, and a date is not time zone safe, meaning. Exactly. So all the characters are varchar. They're not in varchar, which means UTF-8. So it only works in ASCII. Like we're back now in the 70s of programming. So it does something for you, right? But all the nitty-gritty details, all the challenges, it doesn't really solve. And I think what it does is that it just reads the internet and say this is what most people do, and most information out there is US centric. That's made by American people. There's a lot of information about that. So of course it suggests that as the highest prediction. So it gives you an idea, and another thing is also there's no country. So this is a system that will work in US, but if you have any, the Americans that talk about you have US and then you have international. Come on, it's a global world, right? So this CRM system will not support any customers outside your own country, or at least you wouldn't be able to know what they are.
The customer has only one address.
Sorry, one time?
The customer has only one address.
Exactly, also that. Yeah. Any big company have many addresses, many locations, all these issues that of course that you face. So the list is long, and that's not saying you can't use it for input, but I think there's this is a little scary because I think this is what people, come back to your sort of point, people think that this is actually a good program. If you don't know anything about program, you think it's a good program. And that's a little scary because people will ask, but why can't you just use this? And we should actually probably make these systems say, now you got it exactly as you asked it. I'm not myself an expert. I also ask for the UI. I'm not an expert on React myself. I can see what it does. I realized one thing immediately it doesn't do. Not everybody speaks English. I would expect a system that sort of localizes itself to my profile. It doesn't do that. Be that out of the box because all the languages are hard coded. So there's no localization thing is. I think that's a basic thing you do in any programming language today. You don't just do, we don't just do Danish. I don't, most of your clients are Danish, but we don't just do Danish, I presume. We often we have a good framework for doing localization, so it works in any language with data depending on the user's interface and whatever it is. That's what we would expect any system today. But this just sort of comes up with the basic, again, US-centric way of looking at the world. So then that creates so many problems for the rest of us. So when you look at these things, it looks really, really smart, but I don't think it really gets the details that are always the complex thing where we use most of our time. So will this code replace you? Probably not. And we talked about some comment. We talked about internationalization. We talked about localization. We talked about the environment channel there. There was no country. There could only be one address, and the list could probably be much longer. So there's a lot of things it doesn't do. And then somebody would say, yeah, but you didn't tell me. You just asked for basic customer reference system for relationship management system. But the problem is, what does that mean? So when we talk about things, the definition of what we talk about, if it's assuming something as a standard, and it's clearly assuming that you sit in the US, you have a US-centric view, you have no international customers, you only use the ASCII library to express things, you only have one customer. It doesn't say that. You don't know, it's just assuming that. So your perception of what something means might be different, but it has one perception and it doesn't tell you what that perception is. So you have to find these things yourself. And whether you're doing programming or anything else, it has sort of, it has an initial sort of assumption of how the world would be. And I actually made a little study. I took in my presentation here. I basically asked ChatGPT, the policeman and Peter has 2 children. How is that possible? What it said is that it talked about same-sex marriage and everything like that, instead of the obvious thing. A policeman can, or police officer, I didn't say policeman, police officer can actually be a lady. That is not uncommon, but it was pretty obvious to see from the data set. It assumes statistically most police officers historically has been men. So of course, the only explanation could be same-sex marriage. However, then said later on, it could also be that the police officer could be a lady, but that was not its first guess. I think there are more police officers that are ladies than are police officers married to same-sex marriage. I think statistically, it's basically wrong. So, this just talks about that it's biased. It makes assumption based on the data it's been trained on. And so you really, really have to be careful when you use this data. And that's not saying you can't use it, but you have to be aware of these things. And there's so many funny things you can do. What I then also I actually asked it about COVID, sort of a friend of mine for COVID, what should I do? And it comes up with all these things that you should do. And basically asked it here, I have a little bit of friend that has got corona, what should I do? Then it tells you if you're living with a friend, it's important you take precaution to reduce the risk of getting infected and spreading the virus to others. Here's some steps you can take. And then they list a lot of steps. They're all wrong. They are all wrong.
I wouldn't agree with the first step. Don't stay at home.
Stay at home and avoid contact with others. That's actually not correct. That is actually wrong. You should actually not, but it depends on something else. There are other things. And you could go on with the list, wear a mask. Probably not. And you could go on. And then sort of, the problem here is that it is not really incorrect. It's hard to tell when you see this. Nobody would say, stay at home, that's probably good, sort of, yeah, probably good thing. But is it correct? Well, if you're an employer and have a lot of employees and everybody stays at home and they have no internet connection, can't work, you say if you're a production facility, this would be a problem. Productivity will fall in society. This is just a one dimension. There's a lot of things it doesn't include. And if you're a healthcare sort of authorization, sort of govern a society, you have to take many things into consideration of risk. Not only say everybody have to stay home because then there's no buses, no production, no electricity. That's probably also bad, right? So you have to weigh that in. So what government officers do is that they come up with policies on how to react in certain situations. So what they did in Denmark was that they created this. They have an instruction of 11 pages you had to read in this situation. And this guideline changed at some point in time weekly, change weekly. And you know, would this algorithm get that? Probably not, because it hadn't been trained. That had to be safe. It's fair. I didn't really know, but we actually tried to translate this one into a guidance. So what you see here is actually what we work with from PCR Solutions, and we have Norman and Bilal that works with us. So this is actually similar. It's also an AI type of solution. It's a different type of AI. It's called symbolic AI. So basically, what we encode the rules from the text into a model, and then we ask some questions based on the situation. And we will basically ask the questions here. Do you live with an infected? That's the first question. Have you had directly physical contact with the person? Because you haven't been in a room, they might be the same address, but you have been out for a long weekend, it doesn't really matter. And have you been closer to the person 1 meter more than 15 minutes? I think that was a rule of thumb that they asked people. And depending on the answer of that, you would actually take some other things. But I would actually like to show you this live, because I think that this is interesting. So basically what you see here is basically an AI model running below that basically tells you what to do. So depending on what I say, I live with infected, yes. We have physical contact, yes. I've been closer to the person, yes. Then they say you are probably a near contact. And a near contact, in a definition, is somebody that has been exposed to the virus. You probably have to do something, right? So it says you're probably, that is what it can based on this information. And then it says you should probably do something more. So I go to the next step. What it says is that when was your last sort of together? Let's say that was on Monday. And sort of, does the infected has any symptoms? No, but they don't have them anymore. Then they actually ask you, so when did they have the symptoms? From the 16th to the 20th. So I have an overlap. That's actually what I want to have. And then it says you are near contact. Now it has found out. So the point is, it depends. So because if I instead had said I was there yesterday, I think I had to change something else here. Forward. But it depends on what you do. So it would say you're not in near contact, I think. And then it will then ask me the next question. I think let's read things. Just a second here. I have to do these things one more time. No, and then so now it says here you have the conclusion here that you are near contact, and then they ask you. It's a year ago. We had these policies that ask you, have you been vaccinated? And if you say yes to that, there's no need to self-isolation. Actually, this guideline was changed in the fall of 2021, I think 6 or 7 times in Q4, because we have the Omicron virus coming in. Then everybody had to go into self-isolation. They tried to sort of, it's not coming to the country. After 3 weeks, they gave up. And then they changed this recommendation, said if you got the vaccine, you didn't need to go into isolation. Then, of course, if you had not been, could change it. Then it would then ask you, have you been infected before? And if you hadn't been infected before, it would say you need to go into isolation because you have no vaccine, you haven't been infected, and then you need to have a PCR test, and it even tells you the date when should you get these things. And of course, if you had integrated 20 IT system, could then please book these dates for me, so I actually have it. But the point is that you can actually ask it these questions, say, yes, I have been infected. When you ask that question, it will say, well, for how long time ago were you infected? Then, of course, it is, if it's more than 12 months ago, it's the same thing, because the infection is actually there's no effect on of you being infected anymore. If it's less than 12 months ago, it's the same answer as you saw for the vaccination, because it has the same effect. So how does such a model look like? I'll show you here, coming up here. So this is what the model looked like. I'm going to make it a little simpler to look at initially. So basically, these are the questions you can ask. These questions have states, and so all these are things you can ask. This is what you saw in the form coming up, and it comes from the text and say if the person has been. They also ask the same in the text. If you live with the person, they say that in the guidelines. So of course I have a question: do you live with them? Do you live? And then the next thing: have you been closer than 1 meter? Yes or no? Then you ask that as a question. So this text comes. So these boxes that you see here, Then what we do is we add rules to it. So these are the arrows. So the arrows tells you something about what are the things you should do in different situations. And this is why when you saw it here, so when I actually say, did you get this third vaccine shot? If I say yes, I basically change the form because the form will change based on that outcome. And I normally try to explain this as if you imagine you're having a document that you're reading, and imagine you could hide in the document what's not relevant for you. So you sit and read this and say, no, this is not relevant. And then all that text sort of disappears. This is exactly what happens here. So if I have got the third vaccine shot, I do not need to answer, have you been previously infected? Because it's irrelevant. And this is exactly what we say here. If we can find it, let's make it a little bigger. We have a chance to see what it says. It's one of these ones here. Here's the question. So did you get the third vaccine question? And you can see here there's an arrow here, which is basically a rule. And it basically says, if you have been vaccinated, whatever the two means, probably encoded in a nice manner, then you been previously infected. So basically there's a rule saying, if you say yes or no, you will include or exclude another question. So that goes away on the form. And coming back to I can just show it like this, coming back to this one here. So from an efficiency perspective, what is most efficient? Into the program, you got all this code, right? So what's most efficient? You get a long list of things that might be inaccurate or might be wrong or right, or getting the precise questions asked. And I would argue at any point in time, getting the precise thing is much more accurate. And I think what we've been sort of, the whole thing about digitalization, the whole big thing about science is trying to be more accurate. Sort of not saying, well, we think you should do that, but to say then we do research on things and find we should in fact do that. That is what you should do in that situation. Because it's based on whatever study we made, we found out something that we should do. And this is what we strive for. This goes in the opposite direction. It comes up with sort of very general things that might be right, but it takes a long time to consume this information. So if we have, a lot of people talk about now you can use this in customer support, replace it with a call center. I'd be very annoyed personally because it tells me everything that sounds right, but it might not be accurate. And actually, I'm working together with a large company in Denmark. There's a guy that's very enthusiastic, and he said he asked ChatGPT to make a summary of a call with a customer. And it was pretty good at making a summary of it, I have to admit that. Then he asked it, can you please list the agreements that were made? And it made 8 agreements that you had made with the customer. You made 1 agreement. There was only 1 agreement. So what's most efficient? Going through a list of 8 agreements created automatically. It's basically a task list that somebody have to revisit and do at some point in time. Or having the right one. I think everybody can agree having the right one would be much more productive. So having the chatbot creating 8 things you should probably do or look at, or having a sort of an accurate algorithm to create the one thing similar to the Corona I said here is probably better because it's more productive, it'll be more efficient. And imagine having all these steps calling up the customer. We talked about this meeting and whatever text it said. I think everybody will, as a customer, would think, but we didn't agree on that, we agree on that one. You would start to confuse yourself and be a little sort of worried. Did I misunderstood the call? Stuff like that. I think that would sort of not make customer services nice. But again, when you read these things, it looks quite sort of promising. So how could we use this this type of technology? Because I think it's actually useful. Just a comment here. I don't know. So you've seen the 2 things. You've seen the ChatGPT and you've seen sort of what we did with the symbolic AI. From my perspective, I think the symbolic AI type of logic is more accurate. It's based on rules you can explain. Nobody can explain the answers before. Why did ChatGPT say these things? You can't explain them. I can go back in the model as we saw before here. Go back here and say, why do we ask this question? Well, we ask this question only in the situation where you have not been vaccinated. And there's a rule for it. So I can actually see that in the model. It might be difficult to understand, but we have encoded 11-page document into 1 page. Of course, then it's a little more condensed and a little more difficult to read, but it's actually explainable. And I think it's reasonable. I think we have approximately 20 questions and 30 rules here. think that corresponds to, if you read the document, ask a lawyer how many things do you have to do, how many rules are there, how many obligations and conditions do you have in the text. That will correspond one-to-one with it. So having a model like this, from the text to the model like this, it enables you to get accurate answers. So I think there's a difference. You can explain these things and they are accurate. I think that there's a huge difference between these the two things. So let me go back to this one here, presentation. Then I need to go back here into Teams and reshare just a second.
It is shared.
Come on.
So don't need to.
I don't need to.
Yeah.
Yeah, but I think in Teams, they.
I think it is shared because you can see that red.
I think they will see another screen. I think this is odd. So now they will see it. So I think the main message here is that the one is based on predictions. One is based on sort of science and formulas. And I think both has values. They've got different values. I think to getting sometimes to fill in the blanks of ideas, I think ChatGPT would be useful. I think, but if things are inaccurate, I don't think it is a good solution. So I you probably also saw this one. Said, wow, I don't know about you guys, but I don't get $180,000 yearly. Again, it's very US centric, right? And of course, nobody would hire it because it can't program. But just the fact that it's put out there as a message, I find interesting. I found this article also. Is that the end of programming? And they actually asked some question. I'm going to jump back into ChatGPT in a second to actually show you these things. They asked some very simple questions, sort of mathematically. They get it totally wrong, right? It's really, really amazing how wrong you get it. So yeah, I think she made an example. Louise made an example saying, if an apple is 1 and a pea is 5, then how do you create 6? One of them, right? And it said, how do you then create 7? And then it come up with a totally different answer. But I'm going to show you in a second. And it's interesting. So it's important to understand. It doesn't understand the concept of mathematics at all. It's totally statistically what is the next word with the highest probability that we would put up there. In some situations, it makes a lot of sense. So coming back to what did I do before? So what was it that I showed you with this Corona example here? So what we basically do is that we take text. Because text is sort of any law, any regulation is written in text. That's what lawyers knows. What we do today when we create IT system, we take these laws, then we translate it, and we probably translate it, I think in most systems I looked at 7 times. Anybody that played with Google Translate, take any song, children's song, the riddle, put it into Google Translate into 7 different languages, you probably don't get the same when you're there. That's the problem with translation. So in IT system, when you create requirement specs and then detailed design and whatever you do, user stories, features, create the code, you translate all the time. Every time you translate, you risk of losing information. In Denmark, there's been many examples of IT systems that don't follow the law. And of course, nobody sat down and said, let's make a system that doesn't follow the law. Nobody had that intention. I don't think programmers deliberately create things that doesn't follow the law. Obviously, you wouldn't do that, right?
Thanks God, you know.
But the question is then, why do we then get systems again that doesn't follow the law? I think it's simple because you translate. Every time you translate a regulation, you risk losing important details. And this is what happens. So, stop creating requirement specs, stop creating design documents, stop creating all these translations of things, and even stop writing code, because it's actually a bad idea. So instead of being a programmer, I would suggest something else that you should do. So I was actually a little too fast here. So the idea here is actually to not write code. And of course, there will still be written a lot of code, but there's a lot of code that you should not write. So you saw the Corona app there. That's actually a very powerful application because it's faster for me to interact with a system that you saw than reading an 11-page document. I think in Denmark, most people, they were presented with the 11-page document and they look at it and said, I take the phone and call the call center. Even though I had to wait 40 minutes to get through, right? And if you do the business case of it, and I think we computed, we had 6 million people, and I think like 5% weekly that was in near contact. Just compute the number of calls and how long time a call take is like several 100 million Danish crowns monthly to cost to operate the call center. You could probably replace it with sort of what I showed you. I think the reason they didn't do it is that anybody that do IT system knows that if you start an IT system, you might be lucky after 18 months to get something that resembles what you needed where you started. It's because of all these translations. What you do here is you can actually take the text and mark it up into a model. Once you have that model, you actually have this SOP. So you don't need, or this guidance, you don't need to program anything. It has been programmed for you. This is what I saw with the boxes and the arrows. Of course, it's programming. I'm a computer scientist myself. Of course, it's programming, but we tend not to call it programming because it's something we can get lawyers to do, something we can get business people to do. Does that mean it will replace you? I think it will replace a lot of things of the work you do today. And I think you will be very pleased with that because that's the thing that is very, very difficult to write. So when you read these rules that you have to obey sort of in a computer system, have to implement that, you get very long if then else, if then else, if then else. And testing that is correct and really understanding that. And even worse, if you get an error after 2 years of the system, is this correct? It's really, really hard to figure out. It's easier for the lawyer. Then we also have will get the lawyers to actually commit to actually giving a precise and accurate answer, something that is really difficult to get out of a lawyer. They always say on the one side and the other side, and with this sort of limitation, whatever you can do. So that's important. So what we also did a couple of years ago was Hugo, at that time was a postdoc for us. What he did was he actually did a study and said, can you use these NLP algorithms? BERT was the algorithm at the time. We are looking at the moment, can we use ChatGPT for the same? So can we actually ask ChatGPT to read the law text and say, can you please find me who are the actors or the roles in this text? Sort of, what are the activities? What are the questions we ask? And also, what are the rules? So how good is it at that? And I think Hugo computed a couple of years ago that the former algorithm, the first algorithm we did, was 71% accurate. So would you use an algorithm that's 71% accurate? I do either use an algorithm that's 71% accurate, and I like to know it's 71% accurate, meaning I can trust it to some extent, but I also have to be sort of look at it. And I would love that somebody could publish what is the accuracy of ChatGPT, because then you knew when you got in there and say the accuracy is warning, the accuracy is whatever percent. They have no chance to compute that because they don't know what it does. It's neural networks. So it would be hard for them to compute that for every answer. The way Hugo computed it, he basically, of course, he asked the algorithm to find these things, and then he compared it to the right answer, and then he could score how good was it. So basically, the way we use this algorithm is basically you just click in the text, you have the text, you click, then it comes up with a suggestion. And we went one step further. I'm going to show that in a second also. So basically, the way we do it is that we basically, so we apply natural language processing to actually translate the text into the model. This is the 71% accuracy. And once we have the model and the DCI engine, we basically have an application. So, and this application you saw is written without any code. There is no code. If I change the model, it would be reflected immediately. And then the last thing I can do, I can apply process mining. Process mining is a technology where you look into what do people do to actually learn from their behavior and say what a good path through whatever process there is. And you might come up with recommendations like we saw from Amazon many years ago. Other people that purchase this book also purchase this book. That's a nice feature. You might, and it's a recommendation. And that's something that people like and appreciate. So you can use process mining to find out what people do based on data. So that's very useful with these icons on. So basically, this is what we do. I'm going to show you that in a video. Of course, here we do it 100%. So basically, what we do is that we take a text. It's a simple text, and I basically take that text and put it into sort of this model converter, and then I click convert. And when it does that, it analyzes the text. It finds the activities, roles, and then the rules of the text. And then it basically produces a DCR model. So this is a DCR model that was created. I need to Here's the model. So what I can do is I can open this text model here. So now I have two screens. So what you see here is that you have a text on the left when it comes, and you have the model on the right, and just move this one. So what we basically do is that if I select the text here, so it would show me where this text is here. Similar, if I select the rule here, it will show me where the rule is in the text. This means that I can get a lawyer to actually ask the lawyer, could you please find the users? So that what we call the roles over there. So the actors of the process. He marked that with the green, with the green text. So you can see that. Say employee and manager here. Then I can ask him, what are the activities? What are the things you should do? In the text, the questions you should ask or the analysis you should make. So we mark them with blue. And finally, with orange, we mark the rules. And I'll highlight one rule here saying, it says here, whenever an employee fills out an expense report, the money must be paid out within 1 week. So this is within 1 week, 7 days, right? So I am able to make that rule based on that law. If you look at law text, we've explored law text quite a lot. Can you then take a law text and create an IT system? The answer is yes, you can do that. You will get a system that is guaranteed to be compliant with the law, provided, of course, that you interpret the law correctly. And we'll ask a lawyer to do that. That's our best sort of chance to know that we did it. But more importantly, even if there is errors in the interpretation of the law, we would be able to review later on how did we interpret that. So just making a stupid thing here, if I did it this way instead, say I did 1 day here. And of course, when I read this text, we paid out within 1 week. It's one, oh, it says day, not a week. Okay, I did a mistake. I can see that there's sort of some discrepancy here. And I think traceability and transparency from requirements and obligations in laws and other things into models makes it possible to verify that whatever you the text you have as rules is actually the same that as you have as programs. In classical C# programs, it's almost impossible if you ask me, because you have to find the obligations or the rules in a Word document, and you have to trace all the translations to get in the code. And then if you sit in the support department 2 years after the system was made, it's really, really difficult to find out what was the problem. Here we have the interpretation. So the layer of business rules and business logic is something we need to pull out of classical programming. We shouldn't do it. We should create it in systems like we do DCR or other type of system, because it will provide much better quality of the systems. So probably ask if there are any questions to this. Does this make sense?
It's actually helpful to read the graph as well.
Yeah.
To understand what these boxes and relationship means.
Yeah, exactly. And it gives that definition, it gives you the context of what does it mean. And I think the exomatics here actually it was originally created there. So actually use that in the foundation solutions. And I always talk to Ulrich, because Ulrich, project man, he sometimes adjusts the models and he just adds an arrow. Then he's asked me after, it works oddly, why doesn't it work the right way? And then I asked him, could you please explain in wording what was it that they wanted to achieve? And then he actually wrote it down and said, yeah, but that's not what you put here. So once he has the wording, it's easier. So we had to go back in wording all the time. So if you get the wording right, the likelihood you'll get the right logic here is high. If you just add the rules here, you will probably make a mistake. And I was really a pleasure to see Noman and Bilal yesterday. They were playing with a new feature. I should probably show it. So when we want to add a rule, we can either select one of all these rules here. And of course, what is a logical includer? What is a no response? Nobody probably knows. But I think it was you, Noman, that did this last year. So what we actually do is we can actually now, it's a little, I have to make this the full screen so you can see it. So when I select the rule here, it will actually in text explain what it means. So it translates the text. So if I select another rule, it will basically show me what that means. So text is very valuable in understanding. That's how we understand it as humans. And Hugo, who was a postdoc for me now back in university, he said there's a lot of people that try to convert laws into sort of logical programming. That's what mathematicians do. The problem with this is that you cannot get lawyers to do that. If you show them all these formulas and all these ands and ors and whatever they mean, they look at it and say, yeah, but we don't understand what it means, right? So you have to start and you have to stay in the domain of text to make things understandable. So, and I think that's one of the things we forgot in computer science is that, first of all, we put that into Word documents, which is hard to read. It's not part of the program. I know that many systems today produce automatic documentation out of the definitions you can annotate. This is all very, very, very good because it produces something that we can relate to. And we also need to come that with the laws when we convert that, so we know what it means. And then when sometimes we have the laws, but then we put other assumptions in. And actually, in this model, we actually added something. We added an extra line here that wasn't in the original system, because in the original system, you can actually approve and reject before you fill out, because it's like implicit. Everybody would assume that, why would you approve something when you haven't received it? Strictly speaking, you could ask Tibran something and he could say yes, then you can come later on with the official request. So you can strictly do it, but it really doesn't make any sense to do in the model. So we added that text to get these rules. And this is just an example of you can take the text and then you can add interpretations to it to make it sort of easier to understand and easier to use, but you will still be able to document it. If somebody comes and asks, where did that come from? You can find out who added that at what time, and you can find out how these rules work. So that's important. Just skip back here. So what I did was I basically asked it this question here, and it's the same from the article I will share with you. So it says, let's play a simple number game. We always start from the result 0. Now I'll fix some rules. Each rule has a name and allows to add some numbers to the current result. For example, rule apple adds 2 and rule P adds 5. So apple and P give 7. Using this rule, tell me please a sequence of names that give me 9. Then it says, sure, I'll play the number game with you. Here's a sequence that gives 9. PP and apple. That gives 12. So it doesn't get it. It doesn't get what I'm trying to explain to it. And say and try to correct that. This is not correct. PP and apple gives 12, not 9. So it is polite and saying, I apologize, made a mistake. And then I comes up with this one. I find this really, really, really funny. Cherry, banana. I said, where did you get that from, right? It doesn't exist. And then I said, please explain what is the value in cherry, what's the value of banana? And this is actually correct. I have to give it. Okay, fine. It invented something. And I think this is the benefit of the generative AI. It fills out the blanks. It invents things. And I heard a term, fake facts. And fake facts is actually interesting because it invents things. In many situations, it's useful. In many situations, it's dangerous. So you have to be aware of it. But I think in this situation, I actually give it, okay, fine. Then I ask further down and say, sure. Then it explains how it is. Okay, so then I said, can you provide me with a sequence of 5 fruits that gives 367, right? I know that's probably a difficult thing to do. So, and then it comes up with this one, sure. Here's a sequence of 5 fruits that gives 367. And then it says, then they start to put these things on and then add it. But I said 5 fruits. It doesn't understand. You can only choose 5 fruits. Right? I thought it would have invented a fruit, say, a carrot is 300 just to solve the problem, right? But it didn't do that. So it tries to do something, which is basically, and it just continues on. And you can even get it going in infinite loop. There's an Indian mathematician that lives during in the start of the 19th century. They came up with this infinite number, say, and the question is, in how many ways can you get the sum of 100? With numbers. 100 times will give that 90 times plus 2 will give you the number. So how many times can you do it? That goes really, really astronomically. And if you ask it that, it goes crazy. It just starts writing and it just continues. And then eventually it's probably stopped because it goes into an infinite loop. So this is one of the things that can happen. But you can also ask it, and this is where, ask the question, who is Thomas Hillebrand? That is the professor at the university that actually invented these things. So if I ask you this question, this is actually correct. So he's also a German biologist. It's another Thomas Hildebrand. So I'm going to ask it another question. Thanks. Last question. I meant the Danish Thomas Hildebrand. So see if we can find out who that is then. Okay, then says I'm not aware. It's interesting. When I asked it in Denmark, it was aware of Thomas. And the reason I found it funny was that he said, it was almost correct. He said he's a professor at the university, but he got the wrong university. So, which is something, if you Google it, right? Sort of, if you Google that question, I know I'm going to go there. You want to do Google. It's Sweden. Thomas Hildebrand. So you will find here. So this is the biology we saw about before. This is fine, and this is the other guy, right? So Google will actually get this right pretty fast. It got it wrong because it says that he is from the IT University. It's confusing. Denmark is a very small country, much smaller than Islamabad in population and everything. We have so many universities. It's also probably unfair, but he was not in that university. So invented something, which is not the case. Good. I think that was it. I don't know if there are final questions or comments. I hope it was useful. I hope it was interesting to watch. Thanks for the time and the opportunity.
Online papers.
Any questions online from the online participants?
Look at the teams here. We can get that. I did it go here. So if anybody, any questions from the team? Somebody actually wrote in the chat.
No. So,
Just break. Okay, good.
thanks, Morten, on the great presentation, and thanks for the participation.